Hello. Today we again to do a question for mathematical methods. Still Unit 3. Topic is derivatives. So today we focus on the one question as example for tangent and the stationary points. So this question is a complex, unfamiliar question. So let's have a look at this question. Okay, we have a graph function, so we consider this graph of this function called fx equal to x to the power of 2 times by e to the power of 1 minus x. So that's our function. So highlight that. So this is our function. So this is a given condition. So we need to determine the coordinates of any non-stationary. So let's have a look at another condition is non-stationary point. All points can be more than one on the curve where the tangent passes through the origin. So we also, another condition is this tangent passing through 2 points. One is stationary point, a non-stationary point, and origin. So then we also need to determine the equation of the tangent. So this is our final goal. So we let's have a look at how do we solve that. So first of all, in order to determine what is the non-stationary points, so we need to find the stationary points first. So that's involved with the concept of derivatives. So I'm going to start to solve that stationary points. So we all know stationary points is using differentiation. So let's do that. So I'm going to do first we're going to use differentiate fx. So we're now using a product rule, which is 2x times by e to the power of 1 minus x, then plus x to the power of 2, then differentiate e to the power of 1 minus x. So e to the power of 1 minus x, then multiplied by -1. So this is our product rule. So we simplify 2. So we have x as common factor, e to the power of 1 minus x, bracket 2 minus x. So we simplify into, that's the differentiation, derivatives. So we know it's anything to do with the tangent, we know we need to find the derivatives. So let's find the stationary points. So the stationary points occur where when the derivative of x equals 0. So we say, okay, let's say means we say, therefore we need to solve this. So this one we were solving for x1 is 0 and the x2 is -2. All right, so we got 2 x's, so that's one y. So first, y will be first. So we need to find out y. Y will be f0 first, so which is the same as 0. So the second y will be f2. And 2 squared times by e to the power of 1 minus 2. So the answer will be 4e times by e to the power of -1. So therefore, stationary points, so we've got 2 of them, are, first one is 0 and 0. Next one is 2 and E divided by 4 divided by E. So that's the two stationary points. Now we need to, so we decided determine already for the stationary points. So now we're going to find a tangent passing a tangent means a tangent of this curve passing a non-stationary point and the origin. So we don't know what is non-stationary point is. So that means we need to decide that non-stationary point first. So we say let the non-stationary point be, let's say, A and FA. So this is our non-stationary point. So then, so we say therefore, if the tangent passing that point, this non-stationary point, and the origin, so the origin is, we know origin is 0 and 0. So the stationary, so if we find, so the tangent or gradient of the tangent passing those 2 points, so we can determine by rise of a run. So that we say dm will be y2 minus y1 divided by x2 minus x1. So this is the rise of the run. So rise is y2 is we can choose fa minus 0 and x2. So we choose x2 as a, so a minus 0. So the answer will be fa divided by a. So what is fa? We substitute it in the original equation. So fa is a squared times by e to the power 1 minus a divided by a. So the answer will be, cancel a out. So the answer will be a times by e to the power 1 minus a. So this is the gradient of the tangent passing that point. Let's work out something underneath. All right, so let's continue. So, but we know that this tangent is also a tangent of the graph, which is a tangent of this curve. So we know tangent of the curve is also determined by the derivatives. So, but, so let's say we have another, so, but at this point, A is a non-stationary point. The gradient of the tangent can be also equal to a to the power 1 minus a divided by 1 minus a. So this is using this formula here. So we now this the, if I highlight that, so that's the gradient formula, which is the tangent gradient tangent formula. So we say this is the, so if I substitute x with a, so that's the case. So now we've got two equations. So the first one is, sorry, all right, the first one is here, we call equation 1, and this is the equation 2. So we put them together because they are the same thing. So we say A times by e to the power of 1 minus A must be equal to A times by e to the power of negative A. So those two must be equal because they are the same thing. So now we solve this equation so we can find what A is. So let's move everything to one side. Put a 0, so so we put a e to the power A 1 minus A as a common factor. So the answer will be here 1 minus 2, and so there'll be negative 1 plus A, or A is equal to 0. So now we got first A equal to 0, which is here, or next A must be equal to 1. So we got two x's, which is A equal to 0, A equal to 1. However, so if I choose A equal to 0, we know the F0 must be equal to 0 as well. But we know 0 and 0 is a stationary point. So that means we don't want that point because we want to have a non-stationary point. So therefore, the non-stationary point is A equal to 1 and F1, which is, we substituting the original equation, so the answer will be 1 as well. So therefore, the non-stationary point is 1 and 1. So these are our non-stationary points. So if you substitute the original equation, you will find that that's the non-stationary point. So so therefore, if I say this, the tangent passing the non-station, so therefore the tangent passing through origin and 1 must be, so it will be, so very easy to work it out. So the answer equal to y equal to mx, so the m must be equal to 1. So it must be 1. So therefore, y must be equal to x. So that's the final answer. So y equal to x is the tangent passing a non-stationary point, 1, 1, and 0, 0, which is this. Both of those must be equal. All right, thank you. This is our solution. So if you like this video, click. So can you subscribe my YouTube channel. Thank you for watching. Bye.